Excellent. Well, pleasure to speak with you all today. Apologies I can't be there. I took the family to Disneyland where it was my family and 25,000 of other people's children. Apparently there's a lot of germs at Disneyland, so a little under the weather, and my apologies if I cough during the talk. So I want to talk to you about the Eclipse Cyclone DDS, making ROS-II easier, smaller, faster. Also, this presentation links, downloads, everything. You can find them at the bit.ly/Eclipse Cyclone. So that's already posted. And if you want to get in touch with me, I'm pretty easy to find. So just to get things out of the way, how do you use Eclipse Cyclone DDS? So you do apt install, you change your environment variable, and in Eloquent, you can use ROS Doctor to report to confirm which ROS middleware you are using. Try to make it pretty straightforward for you. And that works both with Eloquent as well as dashing. So a little bit about myself. So I work for a company called ADLINK Technology. We're 1,800 people. We're maniacally focused on these topics of edge compute, edge AI, computer vision, IoT, robotics. We manufacture such things. We have factories in Taipei and Shanghai, so we make stuff for the ABB, Epson, Denso. A lot of folks you would know. We're in every GE train, every John Deere autonomous tractor, airplanes, tanks, factories, and what have you. ADLINK also, with our PrismTech merger, we co-invented DDS and we co-chair the DDS technical committee, so we're quite deep in that space. So we care very much about IoT and connectivity, and DDS is an IoT technology. So we have software labs in Netherlands, UK, Paris, Taipei, and India where we work on such things. For myself, so long-time IoT M2M nerd, spent a few years making MQTT open, helping the automakers and tier ones adopt it, launched IBM IoT, pretty passionate about cars, we'll get a little into that. Also, I spent some time, I'm on the OMG board, which is the parent for DDS and a few other fun things like CubeSat, and I'm on the ROS Technical Steering Committee, so pretty passionate about these things. And that's me on a beach in Maui with a turtle. So cars, I figured Stuttgart, so I may as well talk about cars. I've spent a lot of years building advanced technology, concept cars, connected car, AI cockpit, autonomous vehicles, self-driving bus for elderly disabled that speaks sign language, all kinds of things. And the woman in the orange jacket, that's Angela on stage with my work in Hanover. So, and then this one up here, this is fun. Who needs a self-driving car when you could just have your autonomous robot drive your car for you? So that's a project that I did with a university here in North America. So Eclipse IoT. If you think about open robotics and ROS-Industrial, you have this amazing community, these people that have gathered around to focus on the topics of robotics in all its different forms. With Eclipse, Eclipse is a analogous organization that has a focus around Internet of Things, right? That is one of the big areas of focus for the Eclipse community. So you have this group that's really focused on the IoT, the connectivity, the middleware, the security, in doing work that is, we think, directly applicable to what because we are also members of ROS-Industrial, are doing in robotics. And so Eclipse Foundation, it's been around for a while, a lot of projects, a lot of code, a lot of people. The focus areas, IoT and edge, and then how those roll into automotive, and then tools. Again, I think pretty complementary to a lot of the folks that are working around the open robotics for industrial, AMRs, mobile, and ultimately autonomous vehicles. And my friend Stefan over at Bosch, he has some nice things to say about this as well. So Bosch is one of many companies that's deeply invested in Eclipse IoT and this community. So back to robots. So ROS-I, as you all know, right? Willow Garage, it was a platform for research, so had maybe a little bit of reputation of being developed by academics for academics. With ROS-II, what you get is a rewrite where it's restructured as being middleware based so that you can begin to get to the things that we really care about as you get into commercial use and industrial use and autonomous vehicles and things like where you need the robots to be safe, to be deterministic. So you think real-time, functionally safe, and getting to some of the ISO certifications. Not all of it is there yet, but it's well on the path. And one of the big changes with ROS-II is that instead of a software platform developed by roboticists for roboticists, what you also have is you have these big companies coming in, people like Amazon, Microsoft, Intel, ADLINK, others who bring other skills, right? That they are software engineers and system architects and security experts and all the work that Canonical is doing. And I think this is one of the things that's really driving the rapid maturation of ROS-II. So, I think as of Eloquent, if you've been wondering whether to make the jump, I think now is the time, especially if you're doing anything around the mobile robots. If you're doing ARMS, maybe you wait until F-Turtle or you get into it now. So with the ROS-I and ROS-II architecture, so like I mentioned, the big change here is this bit in the middle of ROS-II where you have this DDS-based middleware, this DDS middleware driving the ROS middleware, okay? And DDS, I don't expect you all in the room to be DDS or IoT messaging nerds, but what it is, it's an eventually consistent shared data space atop a publish subscribe message system. So if you're familiar with MQTT, right, so that's a brokered pub sub, think like MQTT, but UDP-based peer-to-peer. Also, DDS, it's not just a wire protocol, but it's actually an architecture. It's an information architecture. And so there's a lot that goes into this. And so Eclipse Cyclone DDS, what is that? So that's an IoT open source project. It's a performant DDS implementation. It's quite small, quite fast, quite easy to use. It's a community that we love GitHub issues and PRs. You have ideas, you have issues, you have questions, you want to make contributions. We're happy to work with you and take that. And it's led by the IoT mad scientist and second generation DDS inventor, Eric Bosan, who you see there on the screen. So Eric has the unique distinction that how some families are, like my family, all my family are military pilots. My both grandfathers, my father, my uncles. Well, for Eric, his father invented DDS, and Eric is a second generation inventor and contributor to DDS. So he literally grew up with this. So the Eclipse Cyclone DDS, what is that? So it's a pure C library, runtime minimal dependencies. It's quite compact. We have people running it on microcontrollers and various very small things. But despite that, you can configure it for a really minimal footprint, and that does have a bit of effect on the throughput and the latency. Or via the configuration, you can go ahead and loosen it up and give it more resources, and it's quite fast. And we'll get into that. And it runs on all the things, right? It runs on the various hardware architectures, the different OS, and because Morgan Quigley and Eric are rather sentimental, they ported it to Solaris 2.6 and Open Indiana, which I think is probably testament to how portable it is that they have it running on a 25-year-old SPARC Station 20 and getting surprisingly good performance from it.
The RAM usage goes from 150 megabyte to 15 megabyte, and we basically have no late and no lost messages. This is a huge improvement in terms of performance, simply changing the DDS implementation.
So that's Alberto and Juan on stage last month at the ROSCON, talking about their work in taking ROS-II and seeing, is it something, could iRobot port their products to ROS-II. So could they get ROS-II running in what is, for the ROS community, a pretty modest, a pretty small footprint? So they're using a Raspberry Pi 2B, and they had some targets around the memory use, and that their target of 20 megabyte, a target for CPU use around 15% CPU, targets around late messages, lost messages, all these things. And what they found is that with dashing with the defaults, they failed all the metrics, but by switching to Cyclone, they were able to beat all of their performance metrics just by changing the RMW. And some other things iRobot's been working on. So for their test environment, they have 1,000 robots on the same network, a lot of topics, a lot of different sub-networks as well. And they want to be able to, from their debugging tools, be able to select and connect to any one of the 1,000 of robots via DDS from within ROS-II. And they had some different ways that they tried to do this, which were unsuccessful for various reasons. And their video will be posted shortly. You can watch it in its entirety. And then they came up with this idea of, if they disable multicast discovery and instead do just unicast instead of multi, could that work? And that did address it. And they were able to do that with the Cyclone DDS by basically going in and explicitly listing the robot you want to connect to. But then that requires configuration changes for each robot you want to connect to. So one of the things that Eric did, he had, thinking about this, had gone ahead and added earlier this year something called domain tag to the DDSi 2.3 spec, okay? And then he implemented iRobot's use case in the Eclipse Cyclone DDS. So now what iRobot's able to do is they can find any Roomba by serial number among the thousands of robots on the network. So you can explicitly choose and communicate efficiently to any robot among a very large swarm. And this is part of the DDSi specification, and it is a feature of Eclipse Cyclone DDS. So encourage you, iRobot, they've published all their test tools for what they were working on doing for wanting to get ROS-II working very small, very fast, very reliably in mobile robots. So you can download and try their test tools on your Raspberry Pi, any other machine. You can also spin up those tools on AWS RoboMaker. You can also spin up those tools on the Construct's ROS Dev Studio, the online ROS-II IDE. They've actually gone ahead and set that up as a ROS-Jack. So other fun things going on. Cyclone is an Eclipse project. Icerox is an Eclipse project. Icerox is developed by Bosch, and it is a zero-copy pub sub for dealing with the volume requirements of autonomous vehicles, where you've got sensor input up to 10 gigabytes a second. Icerox doesn't support the RTPS, the wire protocol. It doesn't have the quality of service and the other aspects that DDS brings, things that Eclipse Cyclone does very well. Eclipse Cyclone, we had not yet implemented the zero copy and shared memory, though we did have it in roadmap. And these are sister projects at Eclipse. And so Bosch and ADLINK, Bosch and the Eclipse Cyclone community are working to integrate these two together to create an extremely fast RMW. So you look at the use case that they were dealing with of all of these sensors, your algorithms, and then your actuators, all your drive controls, and having multiple algorithms, multiple processes wanting to subscribe to simultaneously to these high bandwidth sensors. So things like, LiDAR, multiple cameras, all of these kinds of things. And with the typical middleware, what you see is that it serializes and then deserializes, X copies based on the publishers and subscribers. And so what the Icerox does a zero copy where it copies it in once, and then all them can subscribe to it. All subscribe to the same copy in the shared memory with the memory pool. So I asked Bosch to get some feedback about, their hands-on with the Eclipse Cyclone DDS and to give some feedback about how all this is. And this was the official response that they sent me this morning. Yes. So other things at Eclipse Foundation, the Eclipse Open ADX, the Open Autonomous Driving working group. And so you have these tools, these technologies. And so Eclipse Cyclone DDS, Eclipse ISROX, these are sister projects being integrated with one another. They'll be part of the Open ADX testbed for autonomous vehicles. The reason this is interesting for you is the work that we do here around making these things real-time, functionally safe, static memory allocation, and eventually iterating through them to where these things are ISO certifiable, okay? All of that should be of great interest for you, for anyone who's doing cobots, safety critical, mobile robots, mobile material, management and movement, all of these kinds of things. And then, of course, the reason you do anything is because race car. So, it doesn't matter what the question is, the answer is always because race car. So ADLINK and NVIDIA, we're already working with the Porsche race team. I understand those might be manufactured somewhere near you. We're working with the Porsche race team here in North America, and the Porsche race team also works with Bosch. And now that Bosch and ADLINK, in the race cars, already using Eclipse Cyclone on ADLINK Extreme Rugged NVIDIA Xavier robot controller. And so with the ISROX and Cyclone DDS being integrated together, we'll be able to do even higher volume sensor fusion in the race car. And they're doing some rather interesting things. We can't disclose all of it, but here's a little bit. So with there's also a telecom provider that's part of this, doing some LTE 5G trackside stuff. So you've got the potentiometers on all four wheels. You've got 3D depth camera mounted road facing under the front bumper, and all of this data coming together through these ML models. And so think about being able to calculate many things about the driving dynamic in real time in vehicle. And so here's a little demo of that. And what they found is that with the trained driver model, and they're using a Tensor RT for this, they can use the neural networks to predict with 85% accuracy, steering angle, brake position, throttle position, gear and speed. A lot of things around traction of all four wheels as well. And then smaller mobile things with Eclipse Cyclone DDS. So Rover Robotics had tested a lot of things on their migration from ROS to ROS-II, and they have a rather brilliant blog series I encourage you to read. It's blogs.roverrobotics.com. I'll add it to the links. About their whole journey migrating to ROS-II, which I think would be a really interesting reading. They make this little workhorse, this little mule of a rover that weighs 17 kilos, carries 100 kilos. It's IP67. You can drive it across streams and through mud. If it gets dirty, you hose it clean. And it's drop tested from 2 stories. It has titanium axles. And they start at €5,000, I think, something like that. So it's a pretty amazing price point. And so they're using the Eclipse Cyclone DDS in that, and someone else that's using it, a company that works developing robots for training professional athletes, so for training like $30 million baseball players, and that's called the ACE. And it's using the Eclipse Cyclone for the vision, the model integration, and all of the stepper motors, stabilizers, all of the things. It's a rather complex piece of gear. Think about a robot that is able to accurately recreate any pitch from any ball thrown from any pitcher in a Major League Baseball game, and including curveballs, sliders, fastballs, all of it. Think about being able to throw an 87-mile-an-hour curveball and land it within a few centimeter patch from 60 feet away. So Pretty interesting stuff. And their CTO had some things to say. You know, they had worked with some technologies, and using the Eclipse Cyclone, they were able to get the fast and precise control needed to recreate these throws. And by the way, Rowan does have the best profile photo ever. Other things going on. So there's a military vehicle manufacturer. They're running Eclipse Cyclone in $9 microcontrollers in military vehicles. These little cheap 32-bit NXP microcontrollers, they're doing the intra-vehicle communication, so the vehicle components discover and communicate with one another. I was also told they're doing something on inter-vehicle, but I don't know any details of that. And I can't say who it is, so here's a picture of an old Jeep instead. One of the challenges with ROS-II we've seen is people working with it over Wi-Fi. So with you know, your RViz and whatever connected over Wi-Fi to your mobile robot. Perhaps less of an issue for wired robots, but anytime you say mobile, you start dealing with Wi-Fi, GSM, LTE, and what have you. And so Eric, seeing some of these challenges, seeing what Rover was doing, others were doing, he implemented something I euphemistically call multicast autotune. So if you're familiar with autotune for the musicians, no matter how bad a singer you are, it makes you sound great. It's not that sophisticated, but sort of. It actually inspects the network interfaces to see if it is Wi-Fi, and if so, it makes some adjustments to the SPDP, the multicast settings for the discovery and messaging. And we found that this really sped the NAV2 Wi-Fi bring up while others learned how to implement such change. And there was a big hospital with terrible multipath issues, and when they dropped this in, it just worked with no configuration changes. And at the Las Vegas Convention Center, I pulled out a Wi-Fi sniffer and found 666 Wi-Fi APs, which Eric said is a rather devilish number. And despite that, we had the robots running reliably for 3 days there on the show floor of the Las Vegas Convention Center. So these numbers here, this is just channel, this is part of 56 to 60. Just to give you an idea of how congested the RF spectrum is there. It's basically the Wi-Fi equivalent of electronic warfare. And there's some very fast serialization coming soon as well. So, you know, iRobot, others have gotten some results that they're quite happy with. And you're about to get some additional gains, so like in the next week or so. So things like the 512K LiDAR point clouds, end-to-end benchmarking 2.1 times faster using half as much CPU, and Struck 32K, 5.6 times faster with 80% less CPU. And Array 60K, a little faster, a little bit less CPU. So depending on what kind of data messages you're dealing with, you'll see different kinds of gains. And this is actually a community contribution. So Dan Rose over at Rover Robotics, he's been a huge contributor to ROS-II. He's done a lot of fixes and improvements to Colcon, to NAV2, to RMW, to many other things. He's a rather prolific contributor to the community. And he's really fallen in love with this and has contributed his time doing this work for the fast serialization. And he measured that with his fork of Apex AI's performance test. If you've not tried it, strongly encourage you to get hands on the Apex AI performance test. And then there's some other work still in progress, things that you'll see rolling out here. DDS security, we're looking at that to be delivered by end of month. X-Types is in progress for early next year, and additional language binding. So OMG, DDS, C++ API, Python binding, other things like that. And I already mentioned the zero copy, and then, you know, to support the work that we do in the real-time working group, some things around static memory allocation so that you can use these in functionally safe systems. Middleware vendor benchmarks. You know, I really suggest just try it. The stuff is not that hard. The tools are there, and go get hands-on with it. So you can try it. Here's instructions for that. You can, this link is this presentation and the links. You can also get iRobot slides, their test tools, the Apex AI tool, and all of that. So you see that right here. So all the links are right here if you just go to that link. Also, you can take a look at the Eclipse IoT adopters. You know, who's using the technology, who's having some success and fun with it. Definitely encourage you to take a look at some of this as well. So it's a really great community, and it's got a lot of great people behind it contributing, with contribution from people at Bosch, Open Robotics, Rover, and many others. And that's my talk.